From a cumulative relative frequency plot, we can tell how skewed our data is. It can be skewed right, skewed left, or symmetric if you remember from the CUS video. Here's the same plot of the test scores I used in the last video. Notice that the graph has a slight S-curve. The slight, almost linear S-curve means that the distribution is symmetric. The histogram of the frequency of the same data as shown in the last video also looked symmetric, so its cumulative relative frequency plot makes sense. So if the distribution was skewed right, the plot would rise steeply at first, like this, and then it would level out. That's because its distribution normally looks like this, if you remember. Skewed right looks like this, because most of the data is being added up early on, so that's why we see this huge steep increase, and then it levels out at the end because there's barely any data being added to it. That's why we see this. If the distribution was skewed left, we would see a slow increase at the beginning and then a sharp increase at the end. This is because if we look at the skewed left distribution, it looks like this. So barely any data is being added up early on, and then the majority of the data is being added up at the end of the distribution, which is why we see this steep increase. So I'll label this as skewed right. And skewed left. Obviously, the line in the middle is symmetric, and, we usually like it when our data is symmetric and normal because it's a lot easier to work with, as you'll figure out later on.